The question is whether low-voltage conductors routed to patient care areas are required to be in a metal raceway, similar to the requirements outlined in the National Electrical Code, specifically Section 517.13a. The answer is no. Section 517.13 of the National Electrical Code addresses wiring methods for patient care areas and typically focuses on power circuits and equipment grounding to minimize electrical hazards in these sensitive locations. It mandates that wiring methods in patient care areas must be installed in a metal raceway system, an approved metal cable tray system, or a cable with a metal sheath that qualifies as an equipment grounding conductor. This requirement ensures a robust grounding path, reducing the risk of electrical shock to patients and medical personnel. The intent of 517.13 is to provide a high level of electrical safety by creating a reliable, low-impedance ground fault current path. This facilitates the quick operation of overcurrent protective devices such as circuit breakers or fuses in the event of a ground fault. Metal raceways and metal sheath cables provide superior mechanical protection and electromagnetic shielding compared to non-metallic alternatives. This reduces the likelihood of physical damage to the wiring and minimizes electromagnetic interference that could affect sensitive medical equipment. However, low-voltage conductors, which operate at significantly lower voltage levels, are not subject to the same stringent requirements. Low-voltage systems, such as those used for communication, signaling, or control circuits, pose a low risk of electrical shock due to their inherent voltage levels. Consequently, the NEC does not mandate metal raceways for these conductors in patient care areas. Instead, low-voltage wiring can be installed using wiring methods appropriate for the specific application and voltage level, as long as they comply with the general requirements of the NEC. For example, Class 2 or Class 3 low-voltage circuits, which are commonly used for control and signaling purposes, can often be installed using non-metallic cable assemblies or individual conductors with appropriate insulation. The NEC provides specific guidelines for these types of circuits in Chapter 7 in Article 725, including requirements for overcurrent protection, conductor sizing, and wiring methods. It is important to note that while metal raceways are not required for low-voltage conductors in patient care areas, there may be other considerations that warrant their use. For example, if the low-voltage wiring is installed in a location where it is subject to physical damage, a metal raceway may provide additional protection. Similarly, if the low-voltage wiring is installed in an area where electromagnetic interference is a concern, a metal raceway can provide shielding. In addition, local codes or healthcare facility policies may impose stricter requirements than the NEC. Therefore, it is essential to consult with local authorities and healthcare facility personnel to ensure that all applicable requirements are met. Furthermore, the specific type of low-voltage system and its application will influence the selection of appropriate wiring methods. For example, a fire alarm system, which is a type of low-voltage system, may have specific wiring requirements to ensure its reliability and functionality in emergency situations. These requirements may include the use of fire-rated cables and wiring methods. Similarly, a nurse call system, which is another type of low-voltage system, may have specific wiring requirements to ensure its proper operation and prevent interference with other medical equipment. In summary, while Section 517.13 of the NEC mandates metal raceways or metal sheath cables for power circuits and equipment grounding in patient care areas, this requirement does not extend to low-voltage conductors. Low-voltage wiring can be installed using wiring methods appropriate for the specific application and voltage level, as long as they comply with the general requirements of the NEC and any applicable local codes or healthcare facility policies. Electrical safety in healthcare facilities is paramount, and understanding the specific requirements for different types of electrical systems is crucial for ensuring the safety of patients and medical personnel. Always consult with qualified electrical professionals and local authorities to ensure compliance with all applicable codes and regulations. Considering other sections within Article 517 provides a comprehensive understanding. For example, 517.13b focuses on the grounding of metal raceways and equipment. It states that all metal raceways shall be grounded to the reference grounding bus bar. This section ensures that all metal enclosures and raceways are properly grounded to minimize the risk of electrical shock. Additionally, 517.14 addresses the separation of circuits. It requires that normal and essential electrical circuits be separated to minimize the risk of a fault in the normal power system affecting the essential electrical system. This separation can be achieved through physical separation or by using separate raceways. Section 517.16 covers the essential electrical system. It specifies the requirements for the essential electrical system, which is designed to provide power to critical areas and equipment in a healthcare facility during a power outage. The essential electrical system typically includes two branches, the life safety branch and the critical branch. The life safety branch provides power to systems such as emergency lighting, fire alarm systems, and communication systems. The critical branch provides power to equipment such as operating room lights, patient monitoring systems, and laboratory equipment. Section 517.17 addresses the wiring of essential electrical systems. It specifies the wiring methods and requirements for the essential electrical system, including the use of transfer switches and other equipment to ensure a reliable power supply during a power outage. Section 517.18 covers the grounding of essential electrical systems. It requires that the essential electrical system be grounded in accordance with the requirements of Article 250 of the NEC. Section 517.19 addresses the receptacles in patient care areas. It specifies the requirements for receptacles in patient care areas, including the use of hospital-grade receptacles and ground fault circuit interrupter protection in certain locations. Section 517.20 covers the wet locations in patient care areas. It specifies the requirements for electrical equipment and wiring in wet locations in patient care areas, such as hydrotherapy rooms and dialysis areas. These requirements are designed to minimize the risk of electrical shock in these wet environments. Section 517.21 addresses the anesthetizing locations. It specifies the requirements for electrical equipment and wiring in anesthetizing locations such as operating rooms and delivery rooms. These requirements are designed to minimize the risk of explosion or fire in these potentially hazardous environments. Section 517.30 covers the general care areas. It specifies the requirements for electrical equipment and wiring in general care areas such as patient rooms and examination rooms. These requirements are designed to provide a safe and reliable electrical system for patients and medical personnel. Section 517.60 covers the critical care areas. It specifies the requirements for electrical equipment and wiring in critical care areas, such as intensive care units and cardiac care units. These requirements are designed to provide a highly reliable and safe electrical system for critically ill patients. Section 517.61 addresses the additional grounding requirements for critical care areas. It specifies the additional grounding requirements for critical care areas to minimize the risk of electrical shock to patients. Section 517.62 covers the isolated power systems. It specifies the requirements for isolated power systems, which are used in critical care areas to minimize the risk of electrical shock to patients. An isolated power system consists of an isolation transformer, a line isolation monitor, and associated wiring. The isolation transformer isolates the electrical system from ground, preventing current from flowing through a patient in the event of a fault. The line isolation monitor continuously monitors the impedance to ground of the isolated electrical system and provides an alarm if the impedance falls below a certain level. This allows for the detection and correction of potential faults before they can cause a shock hazard. Section 517.63 addresses the receptacles and fixed electrical equipment in patient care areas. It specifies the requirements for receptacles and fixed electrical equipment in patient care areas, including the use of hospital-grade receptacles and ground fault circuit interrupter protection in certain locations. Section 517.64 covers the lighting in patient care areas. It specifies the requirements for lighting in patient care areas, including the use of emergency lighting and the placement of lighting fixtures to minimize glare and shadows. Section 517.160 covers the application of other articles. It specifies that other articles of the NEC apply to healthcare facilities, unless specifically modified by Article 517. Therefore, it is important to consult all applicable articles of the NEC when designing and installing electrical systems in healthcare facilities. These additional considerations highlight the complexity of electrical installations in healthcare facilities and the importance of adhering to all applicable codes and standards. The NEC is a comprehensive document that is updated every 3 years to reflect changes in technology and best practices. Staying up to date with the latest edition of the NEC is essential for ensuring electrical safety in healthcare facilities. It is important to note that the NEC is not a substitute for qualified electrical professionals. Designing and installing electrical systems in healthcare facilities requires specialized knowledge and experience. Always consult with qualified electrical professionals and local authorities to ensure compliance with all applicable codes and regulations. Proper grounding and bonding are essential for electrical safety in healthcare facilities. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protective devices to operate and clear the fault. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. Proper grounding and bonding can reduce the risk of electrical shock to patients and medical personnel. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical systems in healthcare facilities. Inspections should be performed by qualified electrical professionals and should include a thorough examination of all electrical equipment and wiring. Maintenance should be performed on a regular basis to prevent problems from developing. The electrical safety training is essential for all healthcare personnel who work with or around electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and the proper use of electrical equipment. The use of appropriate personal protective equipment is essential for protecting healthcare personnel from electrical hazards. Personal protective equipment may include items such as rubber gloves, insulated tools, and arc-rated clothing. Healthcare facilities should have written electrical safety policies and procedures in place. These policies and procedures should cover topics such as lockout/tagout, confined space entry, and electrical work permits. Adherence to these policies and procedures can help to prevent electrical accidents and injuries. In addition to the NEC, other standards and guidelines may apply to electrical installations in healthcare facilities. These standards and guidelines may be developed by organizations such as the National Fire Protection Association, the Institute of Electrical and Electronics Engineers, and the American Society for Healthcare Engineering. It is important to be aware of all applicable standards and guidelines and to comply with them. Healthcare facilities are complex environments with unique electrical safety challenges. By understanding the specific requirements for electrical systems in healthcare facilities and by implementing appropriate safety measures, it is possible to minimize the risk of electrical hazards and to create a safe environment for patients and medical personnel. Remember to always consult with qualified electrical professionals and local authorities to ensure compliance with all applicable codes and regulations. Understanding the nuances of the NEC and other relevant standards is crucial for maintaining a safe and functional electrical system in any healthcare setting. This includes not only initial installation but also ongoing maintenance and updates to ensure continued compliance and safety. In addition to the technical aspects, it is also important to foster a culture of electrical safety within the healthcare facility. This involves providing regular training to staff, promoting awareness of electrical hazards, and encouraging the reporting of any potential safety concerns. By creating a proactive and safety-conscious environment, healthcare facilities can further reduce the risk of electrical accidents and injuries. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with qualified electrical professionals and local authorities to ensure compliance with all applicable codes and regulations. Electrical systems are complex and potentially dangerous. It is essential to take all necessary precautions to ensure your safety and the safety of others. Keep in mind that electrical codes and standards are subject to change. It is important to stay up to date with the latest requirements to ensure that your electrical systems are safe and compliant. Remember that electrical safety is a shared responsibility. Everyone who works with or around electrical equipment has a role to play in preventing electrical accidents and injuries. By working together and by following safe work practices, we can create a safer environment for everyone.